like when we really get into it, you have these things called like statements. You don't have to write this down if you don't want to. And then you also have your reasons. And all of these things that we're going to do, the things that you're going to write down, are like things that go in the reasons column. Okay? So all we're doing this chapter is like, we're going to do math that we know how to do, and then we're just going to like explain each step. So some of it might be as simple as just like writing that you added. I think we kind of did this earlier in the chapter, or just earlier in the year. Yeah, it's kind of just like justifying each step and explaining why you can do that step or why you did that step or whatever. Okay? So if I look at this first one, I have 3x minus 5 equals 10, and it turns into 3x equals 15. Well, what did I do to get from 3x minus 5 equals 10 to get to 3x equals 15? I added 5. So literally what we're going to write is addition. To get from this guy to that guy, all we did was add. Okay, technically it's called the addition property, but we're not going to get too fancy about that. Alright. 2 says we have this congruent thing. Remember when you have the equal sign with the squiggly on top? It says congruent. So it says if angle A is congruent to angle B, then I can say they're equal. So the only thing that's changed is your congruent sign turned into an equal sign. When that happens, we just call it the definition of congruence. Most of the, I shouldn't say most, maybe like half. If you put the definition of whatever thing, that's like 50% of our answers, I'd say, especially as we like really get into it. Like definition of parallel, or definition of perpendicular, or definition of like alternate interior angles. That can work for a lot of things. How you will see me write this when we get really into it, so I'm gonna have it right here. I'll write def of congruence. That's kind of like the shorthand way that I will write that. It says the same thing, just I'm not going to write that every time because that's a lot of writing. Okay, the third one says if x equals 33, then 33 equals x. It says the exact same thing, just like flip-flopped. Okay, so when I switch things around, everyone draw that. All it is we call it symmetry. I can say y equals 6 or 6 equals y. I'm saying the same thing. The reason I can say it is symmetry. We don't use that one a ton. Bless you. Because there's really no point in like flipping things around. Sometimes there is, but okay. Here I have this picture. So a lot of times when we get into our proofs, we will be given pictures and you'll have to like prove things from the picture. If you're given a picture like this, what kind of angles are 1 and 2? Throw it back to like the very first chapter. They're what? They're 180. What did we call them more specifically? A linear pair, yeah. They make a line, right? They make a line, which is why they add up to 180. This is just called definition. Can I write def? Is that okay? I'm going to write out definition. Def of linear pair. We know that if you're linear pair, that has to mean you add up to 180. And I think you said right here. I don't know if this works. Okay. Do we have these? Okay. Like I said, we're not going to get really into like using all of these until later on next week, but it's a nice easy Friday, right? Alright, if I have 2xy equals 2ab, then xy equals AB. What's the only thing that's different from here to here? There's no 2's. How would I have gotten rid of those 2's? I've divided, yeah. So this is just division.
So that's right from definition.
If you wrote definition division, I wouldn't dock you, but you can just write division too. When in doubt, I would put like a def of, but I don't get super picky about what you call those. Like if you would have just said linear pair for the last one's a definition of linear pair, I know what you're getting at.
What if you put the definition for all of them?
Like just the word definition?
No, and then like definition addition, definition symmetry.
That's fine.
Okay.
Okay. I have measure of angle A plus the measure of angle B equals the measure of angle B plus the measure of angle C. And then that becomes angle A equals angle C. What happened from the first to the last?
We got rid of the B.
We got rid of the B. How would I have gotten rid of angle B? Yeah, subtraction. Yeah. If I subtract out that angle B on both sides, subtraction, I'm left with just the angle A and angle C. Alright, 7. It says if M is the midpoint of AB, what's it mean to be a midpoint?
In the middle of the line.
You're in the middle. So like, if I drew AB, here's A, here's B, and it says M is the midpoint, M's in the middle.
You need the dash.
What do you say about dashes?
You need the dash.
Yeah, I need the dashes. These dashes literally tell me that AM is the same as MB, which is what this says. Okay, the reason I know that they're the same is because of this word midpoint. So we have the definition of, guess what? Midpoint. A lot of times, if you just take the one, like, key term that's in there and put definition of, I'd say, like, 80% of the time you're probably right.
Is number 8 definition of complementary?
Yes!
Let's go.
See, you're using your logic. So we got 1 and 2 are complementary. Complementary means that they add up to be 90. Complementaries are one key word in there. So we got definition of complementary. Nice job, Dylan. Okay. I think 9 is probably like the trickiest one to remember that it's like a thing. Okay, so I'm starting with AB equals CD and CD equals EF. Well, do you notice how they have the CD in common? Like they're both equal to CD. If they're both equal to CD, then the outside things are also equal, which is what you're left with, AB equals EF. So all we've done is really gotten rid of the middle guy. We call this the transitive. It's kind of like you transition from AB, CD to CD, EF.
Good question.
Yeah, what's up?
How is that different from the subtraction? Like,
So in the subtraction one, they were directly equal to each other. This one you have, you know those two are equal, and you know those two are equal,
okay.
and then you can like combine them kind of. Like a real example of transitive, it's like if Dylan's 15 and Allison's 15, and they know what they're the same age. Well, if you told me that Dylan's the same age as, I'll just make it up.
Oh.
If you two Dylans are the same,
Are you 16?
then it doesn't matter. Then I know that the other Dylan and Allie have to be the same age. Or like if you're wearing black and your friend's wearing black, and then like you match your other friend, then you must all be wearing black. It's kind of like a transit, like there's a middle guy that's connected to both people. Guy or gal, I should say. But alright. We got SO. This is the very first thing we learned, I think. SO plus OX equals SX. Does anybody remember what we called that way back when? Starts with segment.
A line segment.
Yeah, segment addition postulate. We took two small segments, added them together, and it equaled the whole segment.
Sounds like somebody just came up with the word segment addition postulate to make it sound more
Fancy.
That's what a lot of math is. They just like name things fancily, and they're like, the kids will never figure it out. All right, do we have those down?
No,
Right, fast.
you write fast.
All right, this picture 3 and 4. What kind of angles are 3 and 4? They're vertical angles. They're across from each other. I know that they're congruent, which is what it says, because they're vertical. Guess what? These are vertical angles. Technically theorem. If you wrote definition of vertical angles, that's cool. Even if you probably just wrote vertical angles without the theorem or definition, I'd probably give you credit for that. Not probably, I would. The main part there is that you have vertical angles, and that's why they're congruent, is because they're vertical. Alright, here we got AH bisects my whole angle MAT. Bisects means cuts in half, which is why this angle is the same as that angle. What's the key word here?
bisects.
Guess what?
Is it?
Definition.
I wrote that already.
You wrote it already? Technically, it's definition of angle bisect, but if you just wrote bisects, I get what you mean. Alright. Flip the page. Okay, using your front side, we're going to fill out the back side. Okay, so on your front side, I want you to find something that has two things equal to each other. And tell me what we can do. PQ equals PT. I'm not going to add anything, right? It's just not really numbers. Look at number 2. Can I make them congruent to each other? Yeah. If I wanted to say they're congruent, we could do that. I could say PQ is congruent to PT. And looking at number 2, if I add a congruent sign or take away a congruent sign, if I go from congruent to equal, it's just called definition of congruent. Another thing I could do, if you look at number 3, it says x equals 33, then 33 equals x. I could also flip those around if I wanted to. I could say PT equals PQ because of, look at number 3, symmetry. Those are two different options. It really depends on, like I said, when we get into it, it'll be more obvious of like what you would choose and why you would choose it. We're just going over like different options now. All right, number 2, we're gonna draw a picture for number 2. It says we have this angle XQT. Remember when we have angles, that middle letter has to be where your angle is. So the Q has to be here. So I'm going to put like X and T here. And then it says QA is a bisector. Well, what's it mean to bisect again? It means cutting in half. So what's probably the same? Yeah, these angles. Perfect. This angle, XQA, is the same as this angle, AQT. What's the keyword from that number 2? Bisects. So go.
Definition Definition of bisection.
Perfect. Def of bisector. If you want to throw angle in there and get fancy, that's cool too. Number 3, I have this congruent sign. What does it mean to be congruent? They're the same. What's the word for same? Equal. They're equal. Literally, all we're going to do is just say that they're equal. Angle X equals angle A. What's that called?
Symmetry.
Yeah, definition congruence. Someone will use it there too. Anytime you go from the squiggly on top to no squiggly, or you add a squiggly, definition of congruent. Number 4, it says H is the midpoint of DU. Well, let's draw a line DU. Where should H go? In the middle. Alright. If H is a midpoint, what do I know? I need dashes.
I put the dashes in.
What do those dashes mean?
They're equal.
That they're equal, yeah. DH and H are equal. So my conclusion is going to be that DH is equal to HU. And what's the key word from the number 4? Midpoint. So definition of midpoint. Perfect. Got those? Alright. 1 and 2 are supplementary. What's it mean to be supplementary? They add to 180. Guess what? Angle 1 plus angle 2 equals 180. What's the word?
Segment addition.
Hold up. What's the word?
Segment addition.
Supplementary.
Oh.
So I got def of what? Yeah, a word supplementary. Def of supplementary. Alright, number 6. Triangle ABC is isosceles. Let's draw a triangle. Tells me my vertex is A. That means that's at the tippy top. So I got A here, BC. What's it mean to be isosceles? Which 2 sides are going to be the same? A, B, A, C. Guess what my conclusion is? AB is equal to AC. What's the word from number 6? Isosceles. Guess what we're going to have? Def of isosceles. Definition. Alright. We got those? Yeah? Alright. Here, we're given 2 things. The first thing we're given is that O, this guy, is a midpoint of MP. So, can I make this conclusion that MO is congruent to OP? Yeah, I can say that those need dashes. Why would I say that? Definition of midpoint. Alright, I'm also given that P is the midpoint of OE. So if P is the midpoint of OE, is it true that OP is the same as PE? Yeah, so let's put our congruent signs there. And why do I know that? Because it's the midpoint, so I'm going to write F of midpoint.
Could you say like
Since we're given the word midpoint, I'd use midpoint. The only one you can use congruent for is like if you were given that it was congruent and then it turned into just an equal sign. Okay, so now using A and B and our beautiful picture, it says I can conclude that MO is congruent to PE. How can I say that?
Midpoint.
Am I given that they're midpoints? No, so I can't use midpoint. It's like a 1 I can't use midpoint on. You notice that middle guy, OP? Yeah. OP is the same as MO, and OP is also the same as PE. So this OP is my middle guy. That middle guy one, anybody remember which one was? Transitive. Since they're congruent to the same thing, they also have to be congruent. You can also look at what we have in A and B, and you see how they both have OP? If I cross off the OP, I'm left with MO and PE, which is what that is. Okay, like this transitive one is probably the trickiest one to like remember that it's a thing, like how to use it. But, okay. What questions do we have?